Welcome students. In previous class, we discussed significant numbers, scientific notations. Today we shall take up different ways to express concentration for discussion. Mostly the reactions are carried out in solutions in laboratories. It is imperative one has a better understanding of the expression for the amount of substance present in the form of a solution. We can call it the concentration of a solution or the amount of the substance present in its given volume. Solutions are homogeneous mixture of two or more than two components. By homogeneous mixture, we mean that its composition and properties are uniform throughout the mixture. Generally, component that is present in large quantity is called solvent and components other than solvent are called solute. There are several ways by which we can express concentration of the solution, like molarity, molality, mole fractions, and mass percentage by volume or by mass. Let us discuss one by one. Molarity is used to measure concentration of the solution. Concentration of a substance in solution expressed as the number of moles of solute dissolved in 1 liter or 1 cubic decimeter. It is called molar concentration also, and it is calculated by dividing the moles of the solute by the total volume of the solution in liter. N is the number of moles of the solute and C is the concentration of the solution, V is the volume of the solution. So its unit is mole per liter. Molarity of solution depends upon temperature because volume of the solution is temperature dependent. Molarity decreases with increase in temperature because volume of the solution increases with increase in temperature, but the number of moles of solute remain the same. If I am writing here 1 mole molar solution, 1 m solution of a substance. I repeat, 1 m solution of substance means 1 mole of the solute dissolved in 1 liter of the solution. Now we can understand this concept through numericals. 49 grams of sulfuric acid are present in 100 ml aqueous solution. So what is the molarity of sulfuric acid? I repeat this question. 49 grams of sulfuric acid are present in 100 ml aqueous solution. So what will be the molarity of sulfuric acid? For the calculation of molarity, there are some steps. First, find the number of moles of solute dissolved in solution. Then find the volume of the solution in liter. Then divide mole of the solute by liter solution. So, suppose this is beaker. It contains solution and sodium chloride is dissolved. Sulfuric acid is dissolved. So sulfuric acid is solute and volume of the solution is 100 milliliter and mass of sulfuric acid is 49 grams. So, how will you calculate molarity? First, you calculate molar mass of sulfuric acid. It is to number of atoms of each element. Atomic mass of hydrogen is 1 and 2 atoms are present here, plus atomic mass of sulfur is 32 plus atomic mass of oxygen, 4 oxygen atom are 64, equal to 2 plus 32 plus 64, that is 98 gram per mole or 98 then volume. You change milliliter into liter, 0.1 liter. Then find the number of moles of the solute. That is, mass is given here 49 gram of sulfuric acid. This is the mass of solute divided by molar mass is 98 gram mole per mole. Then calculate, it is 0.5 ml mole. This is 0.5 mole. Now molarity is equal to N by V, N that is 0.5 mole divided by 0.1 liter. This is the volume that is given in milliliter. So, you have to change milliliter into liter, is equal to 5 mole per liter. In this way, you can calculate the molarity of the solution. Another way of expressing the solution is molality. It is a measure of concentration of solute in a solution in terms of amount of the substance in a specified amount of mass of the solvent. Molality is the way to express the concentration of the solution. In other words, the number of moles of the solute dissolved in 1 kilogram of the solvent. This is the difference between molarity and molality. In molality, it is in liter, and whereas in molality, volume of the solution is in kilogram of the solvent, not solution. The value of molality does not change with the change in temperature. It is independent of temperature. In this case, mass of solute and solvent in a solution does not change. In molality, mass of the solvent is used and not the mass of the solution. And its unit is mole per kg. Suppose if I'm writing here 1.00 mole per kilogram solution of KCl. What does it mean? It means 1 mole of KCl is dissolved in 1 kilogram of water. Then question number 1. Calculate molality of a solution containing 5 grams of NaCl, sodium chloride, dissolved in 25 grams of water. Yes, again I repeat it. Calculate molality of solution containing 5 grams of sodium chloride dissolved in 25 grams of water. So, first you write molality is equal to number of moles of the solute divided by volume in kilogram and by V, that is in kilogram. Then identify solute and solvent. This is solute and this is 25 gram of water, that is solvent. In this way you can understand this question. 5 gram, this is sodium chloride. This is amount of sodium chloride is 5 grams, mass. This is mass of sodium chloride. And volume is given here 25 grams. This is volume, but it is given here in gram. Then calculate molar mass. First of all, calculate molar mass of sodium chloride. That is 23 plus 35.5 is equal to 58.5. Or 58.5 gram. Yes. Now calculate number of moles. Mass is given here 5 grams. Given mass is 5 grams divided by 58.5 mole per mole is equal to 0.086 mole. Now you change volume into volume of the solvent, that is 25 gram into kilogram. That would be 0.025 kilogram. This is volume in kilogram. Now molality is equal to N by V. N is equal to 0.086 divided by mole divided by 0.025 kg, that is equal to 3.44 mole per kg. So first of all you calculate molar mass of the solute, then find the number of moles of that substance, then change the volume. If it is given in the gram, change into kilogram. Then calculate molality, that is equal to N by V. In this way you can calculate molarity and molality. As you know that numericals are complete mathematical calculations and only practice as many times as possible help understand the concept in chemistry and move ahead with ease. You are advised to do the numericals from the NCERT and other relevant sources. Thank you.